Hello, sixth graders. Today we are looking at least common multiple. Your learning target is I can find the least common multiple of two or more numbers. So on your notes, you should have both the title and the learning target written down. Okay, you need to have this all written down. A multiple is the product of a number and any whole number. So it's when we are multiplying the number. So for 4, the multiples of 4, well, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. So the multiples would be 4, 8, 12, 16. It's like we're skip counting by that number. If we were looking at the multiples of 10, it would be 10, 20, 30, 40. So it's multiplying them together. The least common multiple of two or more numbers is the least of their common multiples excluding 0. Okay, notice we started with 4 times 1 here. That's what we look at when we're looking at least common multiple. So make sure you have all of this written down on your paper. Just like for greatest common factor, there's 3 methods that we can use. So you don't have to do the examples. We'll go through examples together here, but list out the methods. So the first method would be to list the multiples. So skip count by the numbers. So for 16, list them all out. 16, 32, 48, 62, on and on and on. And then same thing with 20. 20, 40, 60, 80, 100 until they line up. The problem with that method is that you could end up listing for quite some time. And if you just make the smallest error, like if you were counting by 16s and you went 16, 32, 48, 60, just the smallest mistake, it would completely throw off your answer. So be careful on that method. The other method is prime factorization. So again, using factor trees, but now this time we do a little bit differently here. We write them in exponential form. We'll get to that on the next slide. And the third method is, again, the cake method. Same thing, but now you take everything on both the side and the bottom, the last row, and multiply them together, where the greatest common factor was only what was on the side. Again, we'll go through these on the next page. Okay, so I do want you to have each method for this problem written down in your notebook. So we're looking at the least common multiple of 6 and 10, and we're going to go through each method. So the first one is to list out the multiples. So for 6, 12, 18, 24, 30, 36. You just kind of go a little ways and then say, okay, let's try the other one now. So now for 10, 20, 30, 40, 50, and then we can look, do they have anything in common? We're looking for the least, so the smallest number that they have in common. Well, I see they both have 30. So that means their least common multiple for 6 and 10 would be 30. Again, multiples, it's like we're skip counting. So skip counting by 6 and skip counting by 10. If we got to 36 and 50 and they didn't have anything in common, then we would have to keep going and list out more multiples. So that's the first method I want you to have in your notebook. The next one, for the prime factorization, make sure you have these steps written down in your notebook. So the first step is to factor tree for each number. So I start with 6 here. 2 numbers that multiply to make 6 would be 2 and 3, both of those being a prime number. 10 would be 2 and 5, both of them being prime. Prime factorize each with exponents. So I'm going to write them in exponential form. However, for this one, I don't have any exponents. So it'd be just 2 times 3 and then 2 times 5. Step 3 says take the highest power of each factor. So all the factors I see here, there's a 2, a 3, and a 5. Now I need to use each one, and I need to take the one to the highest power. So if one of them had an exponent, like between these 2's, if one of them had an exponent, that would be the one I take. But in this case, I just do 2, 3, and 5, and I multiply those together. So 2 times 3 times 5. Well, 2 times 3 is 6. 6 times 5 is 30. So again, least common multiple would be 30. So that's the prime factorization method. The cake method, put the numbers next to each other, upside down division bracket. We're going to find a number that both 6 and 10 can be divided by. They can both be divided by 2. So 6 divided by 2 is 3, and 10 divided by 2 is 5. Now, is there anything that 3 and 5 can be divided by besides 1? No, so I'm done. Now, for greatest common factor, it would have just been the number on the side. For least common multiple, think it makes an L shape by taking both the side and the bottom, and that's what we multiply. So 2 times 3 times 5, which would equal 30. So that's the cake method. Make sure you have all 3 methods written down in your notebook. Okay. So any method works. Just like with greatest common factor, you need to find which one makes the most sense to you. So here I would like you to pause, and I want you to try these on your own, picking whatever method makes the most sense to you. So pause, try them on your own, and then come back. Okay, so for the first one here, 45 and 75, I'm going to do factor trees. So, or the prime factorization. So for 45, it would be 5 times 9, 5 being prime. 9 would be 3 and 3, 3 being prime. So then I write this out using exponents, so in exponential form, so 3 squared, because there's 2 of them, times 5. And now for 75, 3 and 25, 3 being prime, and 25 would be 5 and 5. So in exponential form, that would be 3 times 5 squared. Again, if you did a different method, that's okay. But I want to make sure you see this for this problem. So then it says, take each factor to the highest exponent. So there's 3 and 5. So for the 3's, we have a 3 squared and a 3. The one with the higher exponent would be 3, or 3 squared, sorry. Then the other factor is 5, and the 5 squared has the highest exponent. So we take those, and that's what we multiply together. So 3 squared times 5 squared. So 3 squared, again, that means 3 times 3, which is 9. And 5 squared means 5 times 5, which would be 25. And then if we do some long multiplication here, 45, 18, 19, 20, 21, 22. So that would equal 225. So their least common multiple for 45 and 75 would be 225. And if you had done listing the multiples or the cake method, you should have gotten the same answer. Next one, 3 and 12. I'm going to do the cake method for this one. Put the numbers next to each other. What's a number that 3 and 12 can both be divided by? Well, they're both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. 1 and 4 don't have anything that they can both be divided by except for 1. So I take what's on the side and the bottom, and I multiply that together. So 3 times 1 times 4, which equals 12. So their least common multiple is 12. And notice that it's one of the numbers we started with. That is possible if the other number can be multiplied into it. Last one, 2, 3, and 5. I'm going to list out the multiples here. So the numbers that for 2, well, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. Okay, those are our multiples. I'm going to stop there. Okay, for 3, 6, 9, 12, 15, 18, 21. And then for 5, 10, 15, 20, 25, 30. Is there anything in common so far? I'm just quickly looking through. There's ones that 2 of them share, but so far nothing that all 3 of them share. So that means I got to keep going here. 14, 16, 18, 20, 22, 24. So I know so far none of those. 26, 28, 30. I'm running out of room here. 21, 24, 27, 30. If I notice what just showed up between all 3 of them, so their least common multiple would be 30. And again, if you did one of the other 2 methods, you would have found that same answer. Okay, we have a real world example here. Lucy needs to buy paper plates, napkins, and cups for a party. Plates come in packages of 12, napkins come in packages of 16, and cups come in packages of 8. What is the least number of packages she will have to buy if she wants to have the same number of plates, napkins, and cups? So when you go to the store, of course, all of the party supplies all come in different numbers, but let's say we want them all to be the same. So we would want we would want to have 50 of all of them. Well, that might not be possible. So we need to figure out what's the least number of packages that she'll have to buy if she wants the same number. So what we're trying to find here is the least common multiple for 12, 16, and 8. For least common multiple, my favorite method is the cake method, so that's the one that I'm going to do here. So a number that 12, 16, and 8 can all be divided by, they're all divisible by 2. 12 divided by 2 is 6. 16 divided by 2 is 8. And 8 divided by 2 is 4. Those can all be divided by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And 4 divided by 2 is 2. Now there's nothing that all 3 of them are divisible by, so that's where I would stop, and I take everything on the side and the bottom, makes an L for least common multiple, and I'm going to multiply them all together. So 2 times 2 is 4. That's not a 4. Let's try that again. 3 times 4 times 2, well, that would be 12, 24. So 24 times 4. Let's do that off to the side. 4 times 4 is 16, 96. So I'm going to have to buy, or Lucy in this case, is going to need 96 of each thing. But the question's asking least number of packages. So we want to know how much of each she would need to buy if we need 96 of all of them. So we're going to take 96 divided by the 12 plates, 96 divided by 16 for the napkins, and 96 divided by 8 for the cups. Okay, so 96 divided by 12, I know is 8. So that means she needs 8 packs of plates. 96 divided by 16 is 6, so we need 6 napkins. And 96 divided by 8 is just the opposite of what we had above, so 12. So 12 cups. So that's how many packages of each item we would need to buy. And then in that case, she would end up with the same number of plates, napkins, and cups. So that's our lesson on least common multiples. So you are going to solve these 3 problems in your notes, adding them onto the bottom. I'm not going to go through these with you, but I am going to be looking for these when I check your notes. And if you don't have them, that tells me that you didn't watch all the way to the end, because otherwise you would know you need to complete these 3. So find the least common multiple of 24 and 36, the least common multiple of 8, 12, and 16, and then we're doing GCF, careful on that one, that you don't do least common multiple, greatest common factor of 22, 33, and 44. And I am expecting to see these problems in your notebook. So go back, look over your notes. Do you have everything you need to have written down? Check your understanding. Is this something that you could explain to a friend? If not, you probably should go back and re-watch parts of the video or try some practice problems. For this one, you are not putting your notes on Class Kick. Instead, you're going to be showing them to me in class or on Zoom.